Hello students, let us solve a problem from NEET UG Paper 221. Here is the problem. The problem states that a ball of mass 0.15 kg is dropped from a height 10 meter. The ball strikes the ground and rebounds to the same height. You have to find out the magnitude of impulse imparted to the ball. Since the ball is rebounding to the same height, it is a problem of perfectly elastic collision. So to find out the impulse, we need to know what is the definition of impulse. The definition of the impulse is saying that the impulse of the ball is change in the linear momentum. So linear momentum P1 is the linear momentum of the ball before collision, and P2 is the linear momentum after collision. So now to find out P1 and P2, we have to use the principle of conservation of energy. Let us suppose the ball was at height h, and at this height ball does not have any initial velocity, so the whole energy of the ball is the potential energy, gravitational potential energy, that is mgh. When it starts falling, it develops kinetic energy, or potential energy gets converted into kinetic energy, and that's how it gains some velocity. Just before the collision, the velocity of the ball become maximum, because there the whole potential energy gets converted into kinetic energy. And let us suppose just before the collision the ball attains a velocity u. Hence we can write half mu square is equal to mgh, and from here we can find out u is equal to root over 2gh. So this velocity is just before the collision while approaching to collide with the ground, so that this velocity is called velocity of approach. Velocity of approach. Okay, so velocity of approach, let us write here, that is u is equal to root over 2gh. Now you have to find out the velocity after collision with which it is going or rebounding to the same height. That velocity, suppose v, and that is called velocity of separation. Velocity of separation. And this can be calculated from the definition of coefficient of restitution. Coefficient of restitution is defined as velocity of separation v divided by velocity of approach, that is u. Now for perfectly elastic collision, this E is equal to 1. Hence we get velocity of separation to be exactly equal to the magnitude of the velocity of approach, but the direction is in the opposite to the direction of velocity of approach. Hence we can write minus root 2gh. Now we have got the velocity of approach, that is the velocity before collision, and velocity of separation, that is velocity after collision. Now we can find out the impulse I as P1 minus P2, or change in the linear momentum, to be 2 mu. Now m is 0.15 kg, h you know, that is 10 meter, and g is 10 meter per second square. If we put all the values, then we see the impulse imparted to the ball by the ground will be nearly equal to 4.2 kg meter per second, and hence second option would be the correct answer for this question. Thank you.